Hi, Serge and Meredith. How are you guys doing this morning or this afternoon for you, Serge?
Yeah, hi. Great. Thanks for having us. We're really excited about this class. So yeah, full of ideas, full of things to share.
Oh yeah, we're
Definitely.
gonna we're gonna get lots of knowledge in today. I'm excited to learn because and don't mind me, I'm just adding our LinkedIn Live stuff so we can have people from there. I actually do not know SQL, so I'm going to be learning a thing or two today. I'm really excited about that. It's always good to expand your knowledge base.
Yeah, I think you'll be pleasantly surprised that you probably know more than you think. So you'll be able to put it to use almost immediately.
That is going to boost my ego, and I can walk around later today and say, yeah, I actually know SQL, so
Yeah, I've
yeah,
been knowing SQL. I just
I've
didn't
been
know that
knowing
I know.
SQL. Okay, so now we're live streaming on LinkedIn as well. We've got that going. And before we get started, we're gonna wait a couple minutes for some people to show up. Have a lot of attendees already, which is great to see. But I wanted to talk about something totally unrelated to the data world, unrelated to SQL. Um, let's talk about what were our careers, or can we call it a career? What were our first jobs? Way before starting anything in the data world. Who wants to start?
I can go. So my very first job was babysitting, just within my neighborhood. But when I got my first like actual paycheck type job, I worked in a popcorn store where we made like all different flavors of popcorn.
Oh, I love that. That is
Yeah.
actually so cool. I would be in there every day if there was one near me.
And it still exists. So whenever I feel nostalgic, I can go get myself some good caramel cheese popcorn.
Ooh,
That's
caramel cheese.
It's a mix together. You have half caramel, half cheese.
Oh
Shake it
my gosh. That
up.
sounds
cannot
like a
imagine that
dream.
combination. Uh,
Oh
sounds
my gosh.
sounds a bit terrifying, but who knows?
No, that sounds good, like too good,
No, it
actually.
could
What
be
about
good.
you,
Cool.
Serge? What was your first
Ironically
job?
enough, it was selling popcorn as well, but
What?
in a movie theater context.
Oh, that is too funny. I love that. Wow, I feel left out. I have no career experience in the popcorn world. Maybe I should go get some on the side. I'm trying to
Yeah,
think,
it
what was
was.
my first job? Okay, so I think
Don't say SQL DBM.
technically no. No, definitely not. Luckily for us here at SQL DBM. I think my first job, so my parents are both CPAs, and they were super into the whole child labor thing with me and my brother. So they would just have us come in during tax season and help out with like liking envelopes and just filing things like that. But I guess my first real job that wasn't with my parents. I worked at a boutique in the mall, and it was in like the back corner and nobody ever came in. So it was very boring. And basically I was a DJ. So I would say I was more a DJ than a store clerk. But yeah, that's so funny that you guys both were in the popcorn industry. That is too funny. Okay, so we're right at 9:05. We've got a ton of attendees already here. I say let's get started. What do you guys think?
I'm ready.
Yeah, let's do
Good.
it.
All right, let's do it.
And I apologize. For some reason, my Google restarted. So I am going to start sharing again.
All good.
Okay. Maybe we should give just a little bit of a background of our relevant professional expertise to SQL.
Yeah.
I didn't use a lot of it shuffling popcorn in a movie theater, but since then I've gone on to do other exciting SQL things. And I have, coming up on 20 years now of experience with BI and data related tasks such as data warehouse architecture, front end dashboards, model design. So I've mainly my job was as a data warehouse architect. That's where I spent most of my time. But I like to keep it fresh and kind of see what's happening on the front end and interact with data in a visual way as well.
Awesome. Thanks for sharing that. I think that's very helpful for people to know. But I think a lot of people are super familiar with your background these days, Serge, which is great because you've got a book coming out.
Yeah, there's that thing too.
There's that thing too. All right. Well, it looks like we're ready to really get into it.
Yes. Can everyone, Sarah, can you see my screen okay?
Yeah. Looks
Perfect.
great.
So, welcome to the presentation. I have an agenda that we'll share real quick. We are going to do some introductions, which we've already started. We'll talk about some basic terminology to get you ready to talk about some SQL details, and talk about team collaboration with SQL, who should use SQL and what's the best way to do that. And then we're going to do a coding demo after all of that, and we will leave plenty of time for Q&A at the end, hopefully. And so Serge, you gave a little bit of an intro. Is there anything else that you want to share?
No, as I guess the slide says it all. I'm currently working as product success lead at SQL DBM. So I come from a data warehousing background, but currently I work with our product team to make our tool as relevant as possible in the modeling space. I do these kinds of webinars. I create content, educational, and basically teaching the best practices of modeling of SQL, and kind of a jack of all trades at this point.
Very cool. And then myself, I'm Meredith. I'm a data engineer at High Touch. I'm also a SQL instructor at CoRise. And I've been working with SQL for quite a long time. In a bit, we'll tell some, stories about that. But I started my career as a software engineer, really focused on user experience. But it had a huge component of using SQL. And one thing I found throughout my career is SQL has been the one constant. It's the skill that I've used in every role that I've had. And anytime, as you're interviewing for jobs, the questions, the technical exercises, SQL has just been a huge fundamental piece of that. And so I like to share with others in the data community and even, other departments like marketing and finance, how much benefit you can get by learning SQL. And it really isn't that hard to get started. So that's what we'll talk about today. I think if we just dive right into what is SQL, the acronym SQL stands for Structured Query Language. And here's just a little snippet of what it looks like. We'll dig into the details, but it's as simple as this. We're writing a statement that begins with a select, and then we're going to access our tables, and we can filter and order by our results. So this is just a little snippet of what SQL looks like. There are so many platforms that use SQL. If you've heard of any of these as they pop up, being skilled in SQL will allow you to work with data on all of these platforms. And this is not the entire list. This is just some big ones. So Microsoft SQL Server, which is the first SQL platform I started working in. Oracle is also, I think, still the biggest, most used SQL platform. PostgreSQL, MySQL. And now when we start talking about cloud data warehouse technology, we have Amazon Redshift, Snowflake, Google Cloud, and Databricks. So all of these platforms, if you know SQL, you're already ready to go. I see a comment about a blank screen. Okay.
I think most people can see.
Okay, great. So when we talk about working with SQL, like I said, it's not limited to one group in technology. My early SQL experiences were developing SQL for applications as an application or product development person. In that world, we create a lot of tables and we're optimizing for really fast and accurate data creation. And what's important there is that influences our customers' experience. So even though we're writing SQL in the same way, we design our database a little bit differently. Today, I work with SQL for analytics. And this is where you might have heard cloud data warehouse. That's the big technology that powers analytics. And in this world, we're combining data from all of those different data sources and applications. We have to model the data to make sure that our analytics are consistent. And then our main concern is optimizing so that we can get organizational insights, which means we're going to work with a lot of data. However, the simple syntax of SQL is going to apply across the board. And that's what we'll look at today. I just want to point out, and we won't go too far in depth with this, SQL has been around for a very long time. So there's a few key dates that I want to point out to give you some context. This isn't a new technology that's going to come and go. It's very well established. So the very first appearance of SQL was in 1970 with a paper written by Edgar F. Codd. And that described the concepts that we'll dig into today. Oracle, which at the time was called relational software, in 1979, SQL became commercially available. A really important date is 1986, when the American National Standards Institute standardized the language of SQL. And that's important because there are basic elements of SQL that apply to every platform. So you're not just learning SQL for Snowflake, you're not just learning SQL for Databricks. It applies across the board because of the standardization. Now, one caveat to that is platforms have added functionality on top of the standards, but they do comply to the ANSI SQL standards. And so I think we already did this a little bit in our intros, but I left some time here. Serge, if you have any other SQL stories that you want to tell, or I know we kind of covered it a bit in the intro.
Sure. The first half of my career was spent in the SAP ecosystem. So still related to data. And even though these kinds of systems were a little bit more of a black box, you kind of interacted through a front end. You didn't actually write, in most cases, you didn't write the SQL queries. It still knowing that there's a database sitting behind it and that whatever your front end is doing is affecting and writing queries behind the end in the back end helped you understand kind of the operations that were going on and the efficiency or the non-efficiency of what you were trying to do. So whether you're interacting with it hands-on or you're going through a front end, like even your dashboard, if you use Tableau, if you use Looker, they don't perform anything magic. They don't have an engine that they themselves can crunch through data. They just send queries back to your database. So sometimes you get what you want, they're intuitive. Sometimes it's not exactly what you're looking for. So having the concepts will not only let you write performant dashboards, queries, etc. It will make sure you get the exact result that you intended instead of having some tool decide for you.
Nice. Thank you. The story that I wanted to tell is a big shift that I experience during my career, and it's been probably about 5 years now, that in my view of SQL, it's become a lot more widespread and accessible to a bigger audience. So if we go back, and let's say go back about 10 years, we weren't working in cloud data warehouses. The team that I worked on, we had actual servers on premise. We had a server room, and it was filled with these giant multi-core servers, and that's how we ran SQL. And so one of the concerns that we always had was, first of all, storage was expensive. And so we had to do things in the most efficient way possible. But the exciting change that came about in cloud data warehouse time is we don't have to worry about concurrency anymore. So we would actually lock down users. If a user wanted to go out and discover data or find something for themselves, we were scared because our production environment could go down, if they ran some expensive queries. And so that's what's exciting today, is everyone can use the data. And obviously in your organization, there's possibly confidential or customer data that you can't explore and find out things about individuals. But from a data warehouse perspective, you really have the ability to query SQL and find the analytics and the insights in the data without having a whole big background in SQL or even being on a data team. So I think that's very exciting to me about this topic today.
Actually, I'd like to piggyback on that as well, specifically relevant to what Meredith just said. It really needs to be, it bears repeating of how much of a paradigm shift cloud computing was, and not just because of the scalability and the amount of resources available that you're not going to bring down production. It's the ease of access to the end user. So it really delivers on the promise of self-service. So you don't have to install anything, you don't have to get any patches, updates, drivers, whatever. You log on to a URL, a website, you access with your user. The system takes care of permissions, access rights, so you're not seeing that sensitive customer data. And then you go and you work with the resources that you've been given. So this just opens up a whole door of, you don't have to learn any new tool, new interface, new GUI. It's that same ANSI SQL that's been around since the 80s. And it empowers end users. It lets them finally take control of something that there's no more of those limits of, you can only use it between the hours of 12 and 1 when everyone's at lunch and queries will run faster. It's there for you. So in this class, we're really going to see exactly what kind of cool things you can do with it.
Yeah, excellent point. Thank you. If we go back to our content, team collaboration in SQL is not just for application developers and data teams anymore. Like Serge mentioned, the concept of self-serve analytics means that anyone in the organization can and should look at data. There are a number of tools that make it really easy to interact with the data. And the most important part is we can also easily document the data so that everyone can understand. They're not just looking at a long list of tables. And we'll talk about some techniques to do that. The big asset that you can create as you design a database, or even as you bring a new database into your environment, is the concept of a database diagram. And before we do our demo, we'll step into the pieces around this. But the concept of database diagramming is so important when we start talking about self-serve analytics. You really should be able to share with your organization what are the key entities within our data and how do they relate to each other. So that enables everyone, if they have some type of visual representation of the entities and relationships, that enables them to do self-serve analytics. Is there anything you want to add on this one, Serge?
No, I think you nailed it. It's really, where is the data? You used to go around asking colleagues who has the Excel. Now it's show me an interactive diagram, cloud-based, in sync with the existing database. Where can I find my data? And it really is that simple. You can see a table, you can type a search, just like a search engine, type in the name of the thing you're looking for, customer orders, and it pops up. And we're going to explain exactly how to use these and how they save time when working with data. But just so you know, that's what we're referring to.
Thank you. A question that a lot of people ask is, how do I learn SQL? And we're very lucky right now because there are so many resources and so many people who are creating content around learning SQL. Just a couple examples. I think there's some great people to follow on LinkedIn, Serge being one of them as well, who post about SQL resources and SQL. There's a lot just in social media that you can learn from reading. And then there's also training organizations. I mentioned CoRise is one that I partner with. They have a free SQL crash course that runs every now and again. And right here, things like this, going to webinars, anything that you can learn from these events, from podcasts. There's a wealth of information right now to help you start learning SQL. But the big thing, in my opinion, about learning SQL is just getting your hands on it and practicing and writing code. So if you take something away from this talk today, what I would greatly advise you is to get started. And don't think that you have to learn everything and understand all of the SQL topics before you start writing queries. It is something that's accessible. The things that you need to get started are your database connection and credentials and a diagram of what data exists in your organization.
Yeah, I would just add to that. Besides the actual tools and resources, I think one of the most important thing is an actual challenge, a problem that you are facing in your data life, that you were struggling with an Excel that's so big it hardly opens, or you've got questions that you've never quite figured out how to put the analytics around. So if you take a real problem that you yourself are motivated to solve, then that's when you're really going to try to like come at it from different angles and see if you can crack it, improve it, and do it more elegantly. And as Meredith said, the resources are there. So Snowflake, Databricks, they provide a no credit card, nothing free. Snowflake gives you 400 credits to spend, which is basically months of writing simple queries. Databricks as well, no credit card required. So it really is something that once you figure out how to get your hands on it, by all means, give it a practical use case and see for yourself.
So SQL has become very, is my sound okay?
Yeah.
Okay, great. SQL has become very accessible for all of those reasons that Serge mentioned. We have really easy tools that we can interact through a web platform. You don't have to install or license anything on your machine. You don't have to stand up an environment or, be comfortable with command line interaction. It's very easy to get to the database and to work with the data. But there's some challenges that come with working in SQL. The two big ones that I've seen are, just queries that are hard to understand. They're very inconsistent and long, and just a lot of SQL code within organizations, which one thing that you can do to make some sense of it is the concept of a SQL style guide and having your own standards within the organization. So everybody writes their SQL the same way. Now, this applies if you're creating something that's going to be used over and over regularly. When you query ad hoc, you don't necessarily need to worry as much about style. So when I say ad hoc, it's just, I have a one-time question about the data, I'm going to query and get the answer. But
Meredith,
yes.
are you on that topic? Are you a leading comma or a trailing comma type of gal?
That is an excellent question. I have always been trailing. I did work for an organization that believes strongly in leading. So I switched to it, but it's not natural for me yet. What about you, Serge?
When you learn SQL, all the examples are typically leading or trailing, sorry, trailing. But once you start really using it, you, or at least in my case, I gravitated towards leading. So eventually with enough experience, it's just easier to add things at the end. And that's where you're always adding things anyway at the end. So I know this sounds like crazy to all of you, but we're going to explain what we're talking about in just a minute. You can make up your own minds.
Yeah, let's dig into that in the demo. I do think that we can show some examples around that of why style is important. And then as far as the disorganized data, this is more for the data producers. But really, when you're building analytics resources, if you're on the data team and you're writing DBT or you're creating some sort of data models, naming conventions are so important. Call the table exactly what it is. And then table relationships, and we'll show this a bit more right before the demo. All tables need to have a primary key. And so that's a unique identifier for that table. And then tables to document their relationships should also have foreign keys. So I'll show this in an example, but these two pieces are really critical. They're not something you can create data without doing these things, but it's going to make the data you create very difficult to understand and to work with. So if you are in an organization and you're starting to look at data and you're not finding any of these things to be true in your organization, it's a good question to ask. Really being able to have a diagram that shows the relationships is very important. So let's go back and look at our demo diagram. The demo that we're going to do is a very small, limited demo. This is just a really easy, because we don't have all day to go through this. It's just a very small data set. And this, I have a sample data set that I created just for demoing SQL, and it's called Virtual Kitchen. If anyone has learned with me before, you're probably familiar with it. So that's this VK data schema. And this diagram, first of all, it helps us understand the relationships between these objects. We have a customer table. And then as we can see by the symbols in our diagram, it relates to the orders. So our customer can have many orders. They can have no orders, or they could have many. So a 0 to many relationship. And then orders now have their own relationship with order items. So if I place an order for popcorn, we'll say, since we're popcorn people, I might place an order and get 3 different kinds of popcorn. So my one order with ID 123 is going to have an item for the cheese popcorn, the caramel, the chocolate popcorn, any of those things that I choose. I can have one to many order items between orders. And so having a diagram to understand this relationship isn't, we could have just gone straight to Snowflake and started querying, but being able to see this visually saves us so much time. Really, anyone who's going to use the data, being able to see a good database diagram. Anything else to add to this that might help us before we go, Serge?
No, like you said, a diagram makes it easy. So if your data team has not provided a diagram like this, it's probably because they just love answering questions like how many lines are in an order and where can I find the tax paid. So by all means, ask them.
And what's lucky is we're able to connect our database and generate these. I remember times early on, years ago, where these were manually created, and so they were wildly out of date, which it's important for the database diagram to be up to date. This is the last of my slides. I'm going to switch us over to Snowflake. If there's any questions at this point, please let us know.
We'll also try and save some time at the end, but yeah, feel free to ask either in the chat or only in the chat.
Okay. Oh, that's a great question. Do you want to take that one, Serge?
Yeah, the tool is called SQL DBM. It's an online database modeling tool, and it specializes in precisely that, in keeping the database diagram in sync by connecting and just generating it on the fly. Meredith, the database name, can you repeat the one you're using? And where folks can find it?
The database name, my sample data.
Yeah.
Okay, so I call it, it's just Virtual Kitchen, and I am working on making a public version. It's just, it's a very small sample data set. I built it just for teaching and demoing is all that it does.
Okay, but if in the meantime you have access to Snowflake, so you can see on Meredith's screen, Snowflake actually provides a Snowflake sample data, which contains multiple databases of varying sizes. So it's the TPCH database, and it's actually all the same schema. So once you know the relationships in the tables, you can use them. But those numbers just mean how many records, orders of magnitude, those records are multiplied by. So is it 1 million, 10 million, 100 million? So you can really throw some heavy lifting at them.
Yeah, excellent point. So this is just my little, and these are very small data sets so that we can do this quickly. Is everyone able to see? Would you like me to make it larger, smaller, or is this comfortable to view? Okay, thanks, Anna. All right, so the 3 tables that we showed in the diagram are here. Like I said, it's a small use case. Most organizations, this list of tables is going to be very, very long. So having that visual diagram for the use case that we care about is really important. Let's just begin very simply, and we're going to do a select star from customers. And so I did this because I know it's a very small table. If you're working with a larger data set, it's good to get into the habit of adding a limit. So this would only return up to 10 rows. But I know that I have a very small data set of customers. And the select star is going to return all of the columns. In this particular use case, that's okay, but usually you're going to have tables in the real world that have a lot of columns. And so now we want to start saying, what do I care about from this? And so maybe let's say customer ID, and I care about their username. I have an underscore. So maybe I only care about those 2 pieces. And that's where I would specify the 2 that I care about. For a couple of reasons. One, because it's easier to look at with the data, and it's also more efficient if I have hundreds of columns. And I'll stop here just for a minute and point out that this is what Serge and I were discussing earlier. Right now, because I have multiple columns listed, I need to separate them with a comma. In this case, I did the trailing comma, but Another and very popular option is the leading comma. So both of them will work the same way. It's a matter of preference. And when we have that SQL style guide, it's good as a team to agree on how we write our SQL. So Serge and I could have a little debate of pros and cons, and ultimately one of us would cave and say, okay, let's do the leading commas. But it will work the same way. Run it again. So let's just take a really quick look at what's happening here. So I'm going to take this limit out because we know that we're working with a very small data set. But this is as simple as SQL can be. It's select and from. So those two basic commands, regardless of platform, allow you to start returning the data set. There's very few cases where a single table will be enough to give you what you need. So we're going to talk about how to join multiple tables next. In our case, I just came up with a really easy scenario for us to complete together. And that scenario is we're going to find out what customers have ordered the most items. And we'll create a report by customer of how many items they've ordered. If we remember our diagram, we have the orders table, and then we have order items. So order items is where we go to get our quantity. But because there's not a customer ID in order items, we'll have to go to the orders table first. So now I create an inner join to the orders table. Now we have to specify in our query, how do customers relate to orders? And when we looked at our diagram, we saw that relationship was on a column called order ID. And both of these tables have the same order ID column name. But in order to make our query a little bit easier to work with, and I don't want to type customers and orders every time, I can alias these tables to a shorter name. There's some standards. We could just call it customers, and we could say something like, when we're coming from customers, let's say customers, we'll call it customers every time, or we can choose to give it an alias so that we have less to type. Now that I'm introducing multiple tables, I would need to tell my query which table each of these things belongs to. So we'll call orders O just for speed of typing. And now we have to add that relationship to our SQL query. We'll use the on keyword, and then we say, what are the common columns between these two? So order ID. Oh, autocomplete. Okay. What we've done here now.
Something that I'm sure Meredith can do in her sleep, but can you just flip back to the diagram just to show folks so they can follow along how you knew this, and maybe explain the danger. I think you have it up there on the slides on the other open tab.
Yeah, I do. Thank you.
Okay. The danger of getting this wrong. So
yeah,
I'll let you take it.
Yeah, that's a great point. Thank you for bringing it up. So this is extremely important that we have picked the right field to join on. Oftentimes databases are not named as clearly as this example database. And so all tables have a field called ID, and then there's multiple relationships between the two. I could have potentially, if I don't join it exactly right, my results will be wrong. I might find that a customer has more orders because I haven't picked the right join key between the two. And this diagram really makes it clear because I can see the primary key is the unique identifier for that table. And then the foreign key is any table who refers to a table's primary key. And having those relationships so well documented and defined makes writing the queries very easy.
There's a question. I was actually about to joke about this, but someone asked the question already. Is there a way to test if the results of the join are correct? Yes. So the way you know is if your join is working is if it returns rows from the other table. So in the first example, we just took 2 customer columns, but now we've added a join. So before you start testing the data quality, the first check is, does it bring back data? So if you add another column that you would expect to only exist in the orders table, then does it give you rows in your query? So that's kind of the first way you know. But really the key point is, does it give you the join that you expect? Because imagine if you said orders ID to orders whatever, and they're not the same column, so you get no matches. Then that's a really, you're not going to go wrong misquoting numbers and figures to your boss, because you won't get any. Much more insidious is when you get it wrong. This is what we were saying earlier, is a row in orders single row, or can an order actually span multiple items? So when you make that kind of mistake, what's called a Cartesian join or Cartesian product, what that will do is the system does what you tell it to. You said tell it join customer to orders, and there's 1,000 lines of orders for every customer. Sure, I'll join that. So you're expecting 1 line, but you're getting back totals that have been multiplied by 1,000 or whatever. So not only is this extra processing on the database side, your queries are going to run longer, or they're going to take more credits, but your totals will be off by that factor of 1,000. So instead of $100 order total, it'll be 100,000 total. So that is another really important thing to check before you start quoting your totals or representing them, and are you getting what you'd expect? Which is, you don't have to check the numbers, just check the amount of rows. So if you query 1 customer and you get back 1 row, or you can do this programmatically. I don't want to go too fast. So there's ways of doing it with SQL, order group by having, and you can test, is this working the way it should? But let's just go step by step. And I think maybe we need to, there was another question as well. Can you step back and explain the keywords?
Yeah, thank you.
Inner join.
Yeah, thank you for the question, Mike. So keywords we see in blue, these are words that tell SQL what operation to perform. And so they're also referred to as reserved words. We wouldn't want to create something, an object that's called from. We couldn't create that. It's a SQL reserved word, because from and all of these keywords appear in blue in the query here. They tell SQL their instructions versus identifiers. When I first had a select star, the select star returns all of the columns. And then we narrowed it down to spell out 2 specific columns. The other question was around the inner join. So in SQL, we do have multiple types of joins. I'm not going to go too in depth because of time, and the time is going by pretty quickly here. So inner join is the default, but when we're writing SQL, we often choose to do things in the most clear, explicit manner possible. An inner join means that we're going to return every row from customers that has a row in orders. If I made it that other kind of join, which would be an outer join, we would say, I want customers regardless if they have orders or not. In this scenario, I'm trying to find what customers have the most items ordered. So I use an inner join because I do truly want customers who have orders. Did I miss any of the other questions?
There was one about why is row 2 a star, but I'm not sure what that's referring to.
I think it was a star. We started with star and then we took star away because we realized
Oh.
we didn't need all the columns.
Well, that's kind of like the most iconic line in SQL, select star. So maybe we should explain what that is. Star represents everything. It's a wild card. It's saying, I imagine there's 100 columns in this table. I don't want to type every single one of them out. So star means show me every column. And Snowflake actually added a cool little feature that if you want to include everything, but exclude specific columns, you just want everything except email, you can use the except. But anyway, that's once you've done a lot of typing of column names, you'll appreciate the exclude as well.
Yes. The other point, thank you, Gary. You found that I did it wrong. The customer ID is between the customers and the orders. So I corrected that. Thank you for bringing it up. I was about to ask that, and I wanted to save some time because I think we have a few more interesting things to talk about. Now, at this point, we have a solid query that gets us all of the data points that we need. So that's the first step, is we now have our customers, customer orders, and then the items within each order. Now we can see repetition of customers because customers, as we know, can have more than one order. And then if we look with our order ID, orders can also have more than one line item. Now the piece that we want to add is totaling the amount by customers and orders. And so let's go back to our columns only because this is kind of a large data set now that we've done the join. And in the items table, we have a quantity, and that's the piece that we're interested in. So now we have our customer and we have how many items they've ordered. And in this particular report that we're building, we don't necessarily care about how many orders they have. We're just going to focus on who has ordered the most items. Okay. Now, let's say that we want to sum up, since we see this particular user has 3 and we want to total and start doing some math. We can highlight it here in the UI, but if we want that to be calculated for us, we're going to introduce the concept of group by. And so group by allows us to do these calculations that we call aggregation. It could be a count, it could be a sum, average, max, or min, but all of those require the concept of group by. And now we have to say, what fields do we want to use to group this data? And what fields do we want to aggregate? We have 3 columns, and the customer ID probably isn't that significant anymore for this example. So just to keep our query nice and short, let's say we're just going to group by the username. So that will identify the user. And I could have also typed the column, like I could have typed 1. If you see that, group by 1. I prefer to put the column name to be more clear. And if that column name ever, if we add more columns. So now we're saying group by this username, and we need to do something with quantity, because when we run this group by now, instead of getting 3 rows for this user S Jackson, we'll only get 1 row. And for quantity, we want the total, which we can see here from highlighting is going to be 67. And we can accomplish that by changing the quantity to use an aggregate function. And I'll use the sum. And then let's call it, we want to give it a name to make it clear what we've done here. Now our row set gives us the total for each user instead of all of the details. And yeah, thank you, Gary. Let's go through that real quick. In Snowflake, and we're not going to linger too long because all of the different platforms have different approaches. We could click on the run. The other thing is we can use a keyboard shortcut, which I'm on a Mac, and it's just the control return. And then, yes, you can also use a keyboard shortcut to take multiple rows and using the command and the slash comment and uncomment. But for this one, I really recommend whatever platform and interface that you're using, making sure that you have those commands specific to what you're using.
Yeah, and to Windows users like myself, the command is control. It's the control key. Like exactly what Meredith said, but with the control key.
Thank you. Yes, it's good to talk about both platforms. All right. Now we have created this total quantity. And let's say that we want to filter it out even more. The other piece of queries that you'll see quite a bit is the where. So this is where we apply any filters to our query. In our data set, I have one column, which is on the order table, and it's the order status. And let's say we could have completed or canceled orders. And we only care about completed. We don't want to count any orders that were canceled. To accomplish that, that's where we would put the order status and the filter. All right. Now we've applied that filter. The last thing that I think we want to do here is let's talk about the halving. Halving is a second type of filter. Right now, we're filtering all of the rows in orders that meet this criteria. But what if we want to filter on this criteria, this calculated, aggregated value? We want to apply a filter. In that case, after the group by, we can type halving. And let's say our total quantity is, we want to say, let's say that it is greater than 10. All right, so now we've filtered our result set even further. Is there anything else that you want to add to this basic query, Serge?
Are you going to introduce other features, or can I tie this back to Excel?
Yeah, let's go for Excel. I want to keep it short because we have 5 minutes.
Sure. Okay, in that case, this is why I kept saying you probably already know this, because most of this is not new. SQL is just very simple English words used to do things that you're already used to doing, like select, meaning take, from is what data set. So when you're working on Excel, it's usually one sheet or different tabs. Whereas here you can, using the inner joins, you're combining essentially data from multiple Excel tabs. Where, that's the Excel filter tab, so the little the funnel. And group by is that's a pivot. So sum is the sum, and a group by, if you ever used a pivot table, that's exactly what a group by does. So this is just taking things that you already used in your day-to-day work and making them more dynamic, and also making them as easy to use with this 10-column table as with a table with 10 million rows. It would work exactly the same way. It would run pretty quickly relative to how long your computer would take to open up an Excel of a similar size. So it really helps when people make that connection, that it's really something that they've already been using for a long time. That's all.
Good point.
There's a question, can't you combine the where clauses to, well, moving too fast, to filter the sum as well? So, oh, that's already answered. You can't. Can't you? No, the answer is you can't, because the having specifically, it's there specifically for the things that you are aggregating. So think of them as things in the where are, they exist in the table. They've already been calculated. They exist in the data. Whereas the having some, you first need to sum those up and then you can filter on them. So that's what goes underneath. That's why it has to be kept separate. If you had quantity already summed up in the table, if you're using just like an attribute, then yeah. But this is something you're summing first, then filtering.
Yeah, great question. I think that we've caught most of the questions.
I have a question.
Yes.
So thank you for this. I feel like I learned so much. So thank you. This was awesome. So now that I have this new knowledge, and for all the people in here who they now know SQL and a little bit more about it, or probably a lot more about it, what can we do now? What's the next step? What are some learning resources? And basically, now what?
Yeah, I would say there's two different now what's. If you already are working in an organization and there is data that you can start writing queries against, it would be getting those database credentials, finding out what platform your organization is using and what resources are available to understand that data. If that does not apply to you and you don't have that available, you can go to snowflake.com and set up a trial, and you can use and start working with that Snowflake sample data that will be there by default. We don't have time to go through that specifically, but if you have an email address, you will have access to this database within 5 minutes. It's incredibly easy. You don't have to install anything, just go to the Snowflake website. Anything else you'd recommend, Serge?
Yeah, I think Snowflake, it's famous for making it easy to get started and use. And I'm not biased or anything like that. So I just like Snowflake. And it's easy to get started, but most importantly, they have great documentation, it's free, etc. But it's still a trial. So the important thing is, once you get familiar with it, make sure that you communicate to your data team or whoever administers the access to the data in your company that I've got my bona fides. I know what a select is. I know how to query data. I'm not going to crash your database. And there's really, especially if we're talking on the cloud platforms, there's no danger of that. The access rules are there, the filters are there, and you can't bring down production. So especially the modern cloud platforms like Snowflake and Databricks, they give you dedicated virtual resources that you can use. They can be tagged to your team, to your user. So you can be given a quota of credits or money that you can use in a given month. And once you run out, you run out. So it's very easy to manage. And there's nothing that your administrator can say to you that is a good reason not to do it. Like, oh, it's dangerous because, or you don't have access to this, or we don't have the resources. If you're using it productively and you can guarantee, and there's no risk of doing anything crazy, then it's just self-empowerment, and it empowers your team, and it empowers analytics, and it empowers you to get better results. So make sure you communicate it both internally, that yes, you can work with SQL, but also to the broader organization of, we've got this skill set, now give us a username, give us the access.
Exactly. And I'll wrap it up with the final comment is, I think everyone who's been with us here today is ready to do that, to take one of those two paths and start working with SQL. You know enough to get started, and the more complicated things will come with experience. So thank you for joining us today. This was a lot of fun.
Yeah, this was great. I honestly feel like I have a great foundation for SQL now, and I was at pretty much zero before this. Well, I guess a little bit, but now I really feel like I have a great foundation. So thank you so much, you two, for for teaching us something today. This was fantastic. If anyone else has any more questions that we didn't get to today, feel free to leave a comment on SQL DBM's LinkedIn page, and we'll try to get to those as well. But thank you everyone for participating, and thank you to Meredith and Serge. Have a great rest of your day, everybody. We'll see you again soon.
Thank you.
There will be a recording. That's the final thing. We will post the
Yes.
recording in case anyone missed it.
Yes, absolutely. There will be a recording, so stay tuned for that coming soon.
Okay.
All right. Bye,
Fantastic.
guys.
Thank you, everyone. Thanks for coming.